let's look at the early history of astronomy and the emergence of two important models and the development of the scientific method itself. You need to be able to tell me the difference between the sun-centered and the earth-centered model. Heliocentric is sun, Ptolemaic or earth-centered is the other one. And you should be able to pick these 5 men out on a matching question, but you must be able to explain how the Copernican model explains the seasons. Okay? Ptolemy was a Greek, and he believed the Earth was the center of the universe. And he formed a theory that all objects revolve around the Earth in perfect circles. This was obvious to your observations. Little kids will say, oh, the sun goes around the Earth. You have to be taught otherwise. That seems as obvious as anything. The perfect circle part was dogma. This was the belief that the Greeks had, that the circle was the most perfect shape in the universe. The heavens were perfect, so therefore they must all be on circles. So you have no evidence for that. It's just you want to see that. The characteristic of this model, again, perfect circles. And these things are supported on invisible glass spheres, which the whole universe rests on. And you still have models made like this today, where the stars are like a globe of lights around the little Earth in the middle. What's the difference between dogma and reason? Your belief becomes dogma when you refuse to rationally discuss it or refuse to be open to alternatives. In its worst form, the dogmatic person will destroy the thing they don't like to hear about. So dogma literally means that which one thinks is true, and reason comes from the word consider or think. Lack of reason, incoherence are throughout dogma. Incoherence just means two facts that don't agree. The Greeks who existed before Christianity claimed the circle was perfect. Later, Christian authorities who considered the Greeks pagan decided that everything the Greeks believed was now also perfect. Therefore, if you challenge ancient Greek beliefs, you now challenge the authority of the church itself. If you could prove by experiment that a Greek historical figure that the church had embraced was wrong, you could be killed and all of your works destroyed or banned. The modern Catholic Church looks back those 400 years ago when they were doing that and say, we have no idea what they were smoking. We totally disagree with that kind of attitude. And they apologized in 1980 for what they did to Galileo. But that was way too late for a man whose life was destroyed by people who did not want to believe what his telescope showed. Ptolemy's theory ran into a problem right off the bat, though. He had perfect circles, but the planets clearly do loop-de-loops in their orbit. And the only way for you to understand that is watch this video. Reading about it in a textbook or me talking about it won't show you what this retrograde motion is. You have to just watch the video for 3 minutes and you'll get it. Instead, people that came after Ptolemy modified it and put orbits on orbits. So if Mars is on a Ferris wheel going around Earth, then instead of a single car on the Ferris wheel, there's a little mini Ferris wheel on that. In other words, the orbit of Mars is just a giant spirograph in the sky. Here's an Arab text from the time period showing the path of Mercury, and you can see how many wheels within wheels would be needed to make this system work. It's getting complicated. Copernicus came along and said, I got a different idea. If I pop the sun in the center, then the orbits become really simple and I don't need wheels within wheels. You have to look at that video I said to see the difference, to see in action why this is a much simpler model. But simple doesn't necessarily mean it's the truth. Both models work. Both will tell you where the planets are going to be at any given time. The only nice thing is Copernicus's model, any kid could make in a half an hour with a coat hanger and some marbles. A Ptolemaic model, you're going to be something as complicated as a car transmission. So Copernicus, though, knew his work would be ill-received, so he told people to keep it secret till he was dead. He was so frightened of it. Wise idea, because a monk by the name of Giordano Bruno spoke about Copernicus's theory in an improving way, and the church burned him at the stake. Now, how do we pick which of the two models is the correct one? Well, there's a thing called Occam's Razor. Given two equally probable theories and no way to choose the correct one, you pick the simpler one. So if you have no evidence at all to tell which of these two theories is correct, picking the simpler one probably makes the most sense. It's certainly in the case when, like I said, a kid sits on her dollhouse, crushes it, and the mother comes in and goes, "Did you sit on your dollhouse?" "No." "Then tell me what happened." And the kid tells an elaborate story about an invisible robot coming into their house, crushing it, hypnotizing the parents so they didn't know it was happening. And the mother's like, "But no, you sat on your dollhouse." Any one of us who's been caught in a fib in our life knows that we get caught in a complexity spiral trying to lie our way out of a situation. Now, how did these three guys come in and act as Occam's Razor? How did they separate the two? These three guys were among the three. To have them all three living at the same time is just really quite amazing. Tycho was an observer. Kepler was a thinker. Galileo perfected the telescope. At this time period, everyone would have been shown with swords in their hands in paintings. Notice, Kepler's got a protractor and Galileo has a telescope. This is the thing these men were proud of, their brains, not like, "Look at me, I've got a sword, I can kill people in battle." Tycho was a very rich man from a noble family. He was offered even armies and castles and everything, and he was just like, he was given an island paradise that he made a giant party city that was a giant observatory. A really cool place. Telescopes at the time period look like this: a big protractor, a servant holding a string line, and the guy actually mapping the stars using a big protractor, and some weird creature doggy down here that looks like some sort of half human, half dog. So maybe he was a genetic engineer too. What Tycho got was real detailed observations of the universe. And when he died, Kepler got the data. And Kepler was also deeply religious, and he thought, again, the universe would be circular. He had no problem with the sun being in the center, but he still thought there were shapes that were more magical than others. And to his great disappointment, when he plotted out the data from Tycho, the Earth and the other planets were moving in ellipses. And he was desperately unhappy with that. He didn't like that, but he wasn't a dogmatic man. He was like, "This is what I'm seeing. This is the way the universe is." And the important thing here was he realized if you could watch a comet go around the night sky, say from December to February, he could tell you where it would be 10 years from now. And that's one of the first times in scientific history you had an equation that could predict the future. This was not an easy thing to do. The maximum deflection, this is stretched ridiculously, is 20% out of circle. That would be Earth. The dotted line would be the perfect circle. The solid line is the elliptical orbit. Kepler spotted that by eye, or Tycho did, and Kepler noticed it in the data. That naked eye observations over years, they spotted a 20% deflection in the orbit side to side. Can you imagine if I took a hula hoop to the top of the hill behind the school and I squished it this much out of circular? Would you see that by your naked eye? This is an amazing set of observations. That pretty much showed that the Copernicus model could not only explain everything, but it could predict the future. You could say, well, according to this model, this is where this comet's going to be. And the Ptolemaic system, there's no way you could make it account for that. Now, Galileo's contribution in here, he's misunderstood. He improved the telescope to the point he was able to make a couple of clear observations. That space wasn't perfect. The church insisted that everything in outer space was neat and clean because God didn't like a mess. And he was able to show that the moon was a world like ours with mountains and hills and everything. And when he looked at Jupiter, for the first time in history, we saw other moons. And he was like, look at this. There are these moons going around Jupiter, and they're following the exact rules that Kepler said they would. And this, the church had problems with, because they were like, who's going to read Kepler's work? It's all math. But Galileo is going around pointing this telescope at the sky and telling people, look what you can see. And they ordered his arrest, threatened him with torture. And at age 76, he was sentenced to house arrest for the rest of his life. And he gradually went blind, living in a small home unable to leave. And he said himself, it's